Okay, this is the comparison of electrolysis of copper sulfate using carbon electrodes, which is graphite, or they can ask you platinum also here. And another one is copper electrode, which is active electrode. Okay, we know that carbon is an inert electrode, copper is an active electrode. Okay, so inert and active electrode comparison. First, we'll talk about the inert electrode, what happens in the inert electrode. So we have two cations here. We choose one of them to react at cathode and we choose copper because that's lesser reacted. So copper ions will go here and react there. The reaction at cathode, which is the negative electrode, and this is anode, will be copper ions will gain electrons and form copper, which is a red, brown, or a pink colored solid. So this will be the coating of copper will be the observation here. So cathode pe copper is deposited when the electrode is inert. On the other hand, we need to select the anions to react at anode, and we have SO4 2 minus and OH minus, and we select OH minus. That's the ease of discharge series. So this goes over here, and it produces oxygen. The reaction we know is 4OH minus. So reaction at anode is 4OH minus, gives you 2 water, 1 oxygen, and 4 electrons. So the observation here will be there will be bubbles of oxygen. Now this is what happens in the electrodes of copper sulfate using inert electrodes. Now let's see what happens here when the electrodes are copper. Remember that reaction at cathode remains same. Okay, cathode pe the reaction remains same. So let's write that reaction. Over here, cathode pe same thing happens. What happened there? So copper ions will go here, same as what happened here. And the reaction at cathode will be copper ions gaining 2 electrons to form copper. So there will be copper deposited on the copper electrode. So the electrode will become thicker. Electrode gets thicker. Now over here in the left hand side beaker where there is carbon electrode, reaction at cathode pe copper ions get used up. So because copper ions get used up, the electrolyte will lose its blue color and it will become colorless eventually. Okay, the blue color copper sulfate will become colorless because it becomes sulfuric acid. Obviously, due to the fact that now H plus and the sulfate ions are the remaining, it will form sulfuric acid, which is a colorless acid. So the solution loses its blue color. Over here also copper ions are being lost, so this should also lose its blue color, but it doesn't lose the blue color. Reason? From the anode, the reaction at anode, this is the reaction of what we wrote here, the reaction at cathode. Now reaction at anode, which is over here, the copper ion itself will lose the electron. So the copper atom itself will lose the electron. Copper metal over here itself will lose the electron. So the reaction will be copper losing electrons, and this is the lost electron. This is the copper ion that they form. These are the copper ions which are formed. So over here, copper atoms are being dissolved into the solution. So here copper ion will dissolve from the anode to the solution. So that's how, if you look at the copper ions for concentration, they are getting deposited at the cathode, so their amount should decrease, but they're being added from the anode, more copper ions added from the anode. So copper ions for concentration doesn't change. Hence the blue color in the solution will be retained. So overall effect here is that the anode has lost mass and cathode has gained mass. In other words, the mass, the metal from the anode has actually landed on the cathode, but not directly, of course, via the electrolyte. So mass from the anode will dissolve as ion, and as an ion, it will deposit at the cathode. That's how the anode decreases in the mass and cathode increases in the mass. Okay. This is what net happens. The overall solution content remains same. The copper sulfate remains copper sulfate only, and the metal from the anode goes to the cathode. Now, this is what happens in the electrolysis when you use an active electrode. That simply what happens is that metal from the anode will go to the cathode. Now, this technique is used in the purification of copper. Like this itself is the what happens here is the copper is purified. So at anode, I should take my impure copper, because it may say whatever is impure, whatever pure copper, whatever part is pure, that all copper will go here. And what is not copper or some other metal will all drop down and settle here. Okay, this way the impure copper can be made as pure copper, and the same setup is also can be used for the electroplating. Electroplating again, at the cathode I can keep the object. At the cathode I can keep the object which I want to plate. For example, I have to plate a ring or a watch or a spoon. Whatever object I want to plate, I'll keep it here. And here, this will be the metal which I want to plate on that object. So I want to plate that object with the silver. So I'll take a silver rod here. If I want to plate that object with the platinum or the gold, whatever, I can take that as an anode. Okay, so cathode is always the receiver of the metal. Remember that cathode is always the receiver of the metal. And whenever, whatever is the anode, the solution should be the cation of that metal necessarily. So if this is copper, the solution should be copper sulfate. If it is silver, the solution should be silver nitrate. Remember that if the metal is silver or any other metal, then you take nitrate as a solution. And if it's copper, then you take copper sulfate. Okay, so if it's copper anode, then solution should be copper sulfate. But any other metal, agar hai to take nitrate, because the compound has to be soluble.